All right, good morning, folks. This is Mike coming back at you with yet another video on Introduction to Algebra. In the previous video, we talked about rational expressions as well as simplifying irrational expressions, factoring the top and bottom completely and then canceling out common factors. And then we talked about a special kind of canceling slash simplification that gives us something that's equal to -1. In this video, we're going to talk about multiplying and dividing rational expressions. Well, as sort of a quick recap, when we just had fractions and we just had numbers, we multiplied fractions by multiplying the tops and multiplying the bottoms. And when it came to dividing fractions, what we would do is we would take the second fraction, we would flip it, and that would change the division into multiplication, and then we'd multiply the tops and the bottoms there. Well, we do the exact same thing when we are working with rational expressions. It works in the exact same way. This is nothing brand new here. There's no brand new revolutionary concept that's going on here. We're just using the same concept but with new things. So let's multiply and divide some rational expressions, and we're also going to write our answers in lowest terms. So looking at the first one here, 15a squared divided by 14 times 7 over 5a. Now, something that you don't have to, but you can do, is look at the numbers in front first. And you can see that, okay, we will be multiplying these tops and we'll be multiplying these bottoms here. So let's sort of see if there are any common factors between the numbers on the top and bottom that we know that we'll be able to cancel out and just make it a lot nicer to sort of work with. So here I have a 15 on the top. Here I have a 5 on the bottom. So maybe I can sort of simplify that and make that at least a little bit nicer before I get into too much of the other work. 15 over 5, well, 15 is 5 times 3, and 5 is 5 times 1. So that 15 turns into a 3, and that 5 turns into a 1. Here I have the 7 and the 14. 14 is 7 times 2. 7 is 7 times 1. So when I divide and cancel out that common factor of 7, I'm going to have a 1 here, and I'm going to have a 2 here. So here I have 3a squared times 1 all over 2 times 1a, or 2a. And now it's pretty nice to sort of simplify all this out. 3 and 2, those just have to be left as they are. We can't simplify those numbers in front any further, but a squared divided by a gives me a. So I have 3a over 2, or 3 over 2, then times a. Looking at this one here, 16z to the 4th divided by 6z to the 5th times 9z to the 5th over 8z. The other thing you could do is, if you don't feel comfortable, trying to simplify the coefficients or the numbers in front first, then you can just multiply these things and then from there begin your simplification. So here, if I just multiply the tops, I get 16 times 9, which is 144. And then z to the 4th times z to the 5th is z to the 9th, all divided by 6 times 8 is 48, and now z to the 5th times z is z to the 6th. So now we have some work and some looking at that we have to do here. If you do 144 divided by 48, you'll find that you get 3. And if you do z to the 9th divided by z to the 6th, we're subtracting those exponents. So I have z to the 9 minus 6, or 3. So those were a couple sort of nice basic samples. Some things that are a little bit more involved, though. Things like this: 2x minus 6 divided by x times x plus 1 over x squared minus 6x plus 9. When you multiply these things, once you do the... In fact, I'll say even before you do the actual multiplication, factor everything as much as you can first, because then you may see that there are some common factors on the top and bottom which you can cancel out. So the 2x minus 6, I can pull out a common factor of each of these, or from each of these two terms. I can pull out a common factor of 2, and I'm left over with x minus 3. So there's my first rational expression, times I have my x plus 1, and now x squared minus 6x plus 9. Can we factor this? I need two numbers that multiply to positive 9 and add up to negative 6, and those numbers are minus 3 and minus 3. So now we have this factored, and now we can multiply the tops and multiply the bottoms. So I have 2 times x minus 3 times x plus 1 divided by x times x minus 3 times x minus 3. And you see that we have a factor of x minus 3 on the top and a factor of x minus 3 on the bottom. We can divide and cancel those out. So I have 2 times x plus 1 divided by x times x minus 3. And this one here, some factoring can certainly happen here. X squared minus 1. This is a difference of two perfect squares. X squared minus 1 is equal to x minus 1 times x plus 1. X squared minus 16 is also a difference of two perfect squares. You have x minus 4 and x plus 4. So now we can multiply these things, and we can cancel out and divide out any common factors. X minus 1, x plus 1, x plus 4, x minus 4, x plus 4, x minus 1. So x minus 1 on the top divides and cancels out with x minus 1 on the bottom. X plus 4 on the top divides and cancels out with the x plus 4 on the top divides and cancels out with the x plus 4 on the bottom. So what am I left with? X plus 1 divided by x minus 4. Now on to some division. Again, we don't want to have to divide a fraction, so we change it to multiplication And when we change it to multiplication, we have to flip the second fraction, or flip the second rational expression that we have here. So this is 4 divided by 3y minus 6 times, and now flip this guy, y minus 2 divided by negative 11. So now let's factor things. Let's see what we can sort of cancel out here, if you will. This first one here, I have 4 on top. I notice that I can pull out a common factor from each of these two terms. I can pull out a 3. So I have 4 divided by 3 times the y minus 2 times y minus 2 divided by negative 11. So here I have 4 times y minus 2 divided by the 3 times the y minus 2 times the negative 11. And here I see the common factor of y minus 2 on the top and bottom, so I can divide and cancel that out. So what do I have left with? On the top I have 4, and then on the bottom I have 3 times negative 11, or minus 33. Going over here, doing some more complicated ones that are a little bit more involved. Looking at this one here, we will change the division into multiplication. M squared minus 4 divided by 8m minus 16 times 8m plus 16 divided by m squared plus 3m plus 2. Now let's do some factoring. M squared minus 4. This is another difference of two perfect squares. Gives me m plus 2 and m minus 2. The bottom, 8m and 16, I can pull out a common factor of 8. And what am I left over with? I'm left over with m minus 2 times, now the 8m plus 16, I can pull out again a common factor of 8. What am I left over with? I'm left over with m plus 2. And now on the bottom here, m squared plus 3m plus 2. I need two numbers that multiply to 2 and add up to 3. Those numbers are 2 and 1. So I'll have m plus 2 and m plus 1. Now we multiply and then we cancel. So m plus 2 times m minus 2. I'll write this 8 out front here because that's just typically what we do. And then another m plus 2. On the bottom, 8, m minus 2, m plus 2, m plus 1. I see an m minus 2 and an m minus 2. I see an m plus 2 and an m plus 2. And then I have 8 divided by 8. So in the end, I'm left with m plus 2 divided by m plus 1. So really the key thing here is just saying, okay, when you have it down to multiplication, if it's not already handed to you like that, the key then is to factor things as much as you can and then find those common factors on the top and bottom and cancel those things out. So guys, that concludes our video on section 6.2. If you have questions or comments, please be sure to reach out to me, guys. Emails, phone calls, in-person visits, online visits, flare signals, SOS bonfires, telegrams, whatever you need to do. Until the next video, take it easy, guys.